So here I have asked Desmos to graph a function for me. This is a rational function. The function is x squared minus x, all of which is divided by x cubed plus 1. Now, I've said before that rational functions satisfy the direct substitution property so long as we are inside its domain. This formula is defined everywhere except for x equals 1, which I can see from this asymptote right here. So we will never actually get to the coordinate x equals 1, minus 1. But everywhere else, this function is continuous. So if you wanted to take a limit as x approaches 4, come in from the left, come in from the right, well, I know that it's just going to be the value of the function when x equals 4. So 0.185 is what Desmos is telling me. Let's take a look at a function that's continuous in some places and not continuous in others. So I'm going to use a different function called the ceiling function, y equals ceiling of x. And all this function is doing is giving me the next largest integer than x. So if x equals 1, I get 1. X is already an integer. For x being 1.2, say, the ceiling function is going to be 2. For x equals 2, the ceiling function is going to be 2, and so on. So it just makes this nice staircase shape. Now, anywhere on this flat line piece, this is between x equals 1 and x equals 2, the function is continuous. The y coordinate is always going to be 2 here. So as I'm taking a limit, let's say I'm trying to get to x equals 1.5. Coming in from the left, my y coordinate is pretty close to 2. Coming in from the right, my y coordinate is close to 2. So this limit will be 2, which is the value of the function there. Now, the only problem is that I have left and right limits that are different from each other every time x is an integer, every time x is a whole number. The left limit is going to be the smaller limit, right? So coming in from the left, I get 1. Coming in from the right, I get 2. So my limit, my two-sided limit of the ceiling function does not exist so long as I am taking the limit of x tending towards 1. And that would be the same thing happening as x tends towards 2, or as x tends towards 3, and so on. So this ceiling function is continuous at any coordinate a, which is not an integer, and it is discontinuous at any coordinate a which is an integer. So some places this function is, some points this function is continuous, other points this function is discontinuous.